All right, this is the review for the pre-calculus chapter 5 test. And question number 1 wants us to express this log in exponential form rather than logarithmic form. So just remember the rule, it's 5 to the x, write it over here, 5 to the x equals 625. And then it wants us to solve for x. So this is part of the answer. So I would need to see this. And then to solve, you could use your calculator, do the change of base formula, and could actually just plug this in, do the change of base formula on your calculator, or match the bases. 625 is 5 to the 4th. So I have 5 to the x equals 5 to the 4th. And if the bases match, then we have that law that says x equals 5. So 2 answers to that. This is one of the answers to write it in an exponential form. This is the other answer. Okay. The natural logarithm has a base of e. Okay. I'm going to switch over. I condensed this to make it one-page printing. So I'll switch over to a piece of paper here for number 3. We have 3 to the negative 4 times 3 to the negative 2 over 3 to the negative 1. And now that I look at that small print more closely, that's supposed to be 3 to the positive 4. So we'll get rid of that negative on there. So what I would do is handle the top first. We have the same base. I would add the exponents and get 3 squared over 3 to the negative 1, and then I would bring this up. You can think of it as you subtract the exponents, 2 minus negative 1, or when this comes up, it becomes 3 to the positive 1, and then you add the exponents. Either way, we're going to get 3 to the 3rd, and we should figure that out. That's 27. And you could also punch this in your calculator. With that numerator, if you punch it in your calculator, that numerator would have to be in parentheses. Or press enter and then divide by x to the 7th times x to the 3rd. I can't remember if it was a pre-calculus student or an algebra student, because we're kind of doing the same thing here. But they were supposed to write this as with fractional exponents, and they made this 7 over. They thought this was a 1. And remember, when there's nothing written there, it's actually a 2. So this is x to the 7 halves times x to the 3 halves. And then I have the same base. I can add those together and get x to the 10 halves, which is x to the 5th. 7x to the negative 2/5 times 5x to the 3/5 over 3 to the negative 1. So the only thing being raised to these fractional exponents are the x's, not the 7 and the 5 in there. So I would combine the 7 and the 5, and then I would combine these, add them together. I'm going to get x to the 1/5, and then that's over 3 to the negative 1. When that comes up to the top, it's just going to become 3. So when I take 35 times 3, that comes up, 35 times 3 is 105, I believe. X to the 1/5 would be my answer. Also, you need to work on making sure that your exponents look like exponents and not mixed numbers here. I don't, that's going to be questionable to me. Okay, it needs to look like it's an exponent when you write that. And of course, I wrote the problem down wrong. Where did I get 3 to the negative 1 in the denominator? Gosh golly gee willikers. I shouldn't do these on Sunday mornings. Let's do this problem again. I have 7x to the negative 2/5 times 5x to the 3/5. I had the numerator correct, but the denominator is 15x to the negative 4/5, which is going to be a completely different story in the bottom, obviously. So again, I would do the same thing in the top. 7 times 5 is 35. Add the exponents, I get x to the 1/5 over 15x to the negative 4/5. And what I'm going to do is I'm going to move this up. And again, you can think of it, when I move it up, I'm going to add the exponents, or to get what I'm going to have in the numerator, I can subtract those exponents. Either way, I'm going to get x to the 5/5. And x to the 5/5 is the same as x to the 1. So there you are. And then I'm going to divide, I'm going to take the common factor of 5 out of both of these. So I'm going to have 7x over 3. That's my answer now. Number 6 is 5 to the negative 3 times 5 to the negative 2. We had problems in the homework where we had to multiply these and simplify, which are infinitely easier than the ones in the homework where we had the sign in between here was addition. Because with it being multiplication, I can combine these two things. I get 5 to the negative 5, and that's being raised to the negative 1 power. And then I can raise it to the negative 1 power, and I get 5 to the 5th. And I'm not sure what 5 to the 5th is. I know 5 to the 4th is 625, so 625 times 5 is 3125. And again, you could also punch this in your calculator with parentheses, just the way it is, and get the right answer doing that as well. Okay. Number 7 is 625 x to the 48. Go big or go home there, huh? To the negative 1/4. That's why. So I would probably flip this over and make it 1 over 625 to the 1/4, and then x to the 48th to the 1/4, and then 625 to the 1/4 power is 5. 625 is 5 to the 4th, and x to the 48th to the 1/4 power is x to the 12th, and that would be the answer to that one. Okay. Number 8 has 9x to the 8/3. Where did I come up with these numbers? And 12x to the negative 5/3. So the 9 and the 12 are not being raised to that power, just the x's are. And so I would simplify the 9 and the 12 separately, divide them both by 3. I'm going to have 3 in the numerator, 4 in the denominator. And then I'm going to bring this up. And when I do that, I'm going to have 3x to the 8/3 minus negative 5/3, or 8/3 plus 5/3 is 13/3 all over 4. 4 doesn't get to come up, not being raised to a negative power. Okay? Number 9. 6x all to the negative 2 equals 4. And you have to look at these problems and say, okay, is this the problem where I match the bases, or is this the problem where I get rid of that exponent? And it's the second type. Okay, x is not in the exponent. It is in just where regular down there where it's supposed to be with the 6. So what I do is I take this and I raise both sides to the negative 1/2 power. Because when I multiply those exponents, then I get positive 1. But if I raise this side to the negative 1/2 power, I have to raise this side to the negative 1/2 power. So over here, I get 6x. That's the beauty of it. Over here, I get the square root of 4 is 2, but because that's negative, it's going to be 1/2. And then I would divide by 6, and x is 1/12. Number 10 has 3 to the x equals 81 over 27 to the 2x. So the exponent here is a variable. So this is where I need to try to match the bases. And if I can't do that, I use the natural logs, but I can match the bases. Everything goes to 3. 3 to the x equals 81 is 3 to the 4th, and 27 is 3 to the 3rd, but that's being raised to the 2x power. So that's 3 to the 2x. And then, I'm sorry, 3 to the 6x. Okay, and so then I want to make that 3 to the 4 minus 6x. When you're dividing, you subtract those exponents. And now that I have the same base, I can set the exponents equal to each other. And so I would move the 6x over here and get 7x equals 4. X is 4/7. And that is okay. Okay. Let's see. Number 11. Log x equals 4. Solve, express your answer as an exact fraction. So this, I just need to apply the rule for moving it from logarithmic form to exponential form. Remember, if there's nothing written here, it's understood to be 10. And so the base to this power equals x. So that is 2, 3, 4, 10,000. Okay. 12 logged to the base x of 125 equals 3/2. So again, the base to this power equals 125. And then how do I solve that? I'm not matching the bases because the x is the base. So I solve it by raising each side to the 2/3 power. Because then when I multiply those exponents on the left, I get 1. You can throw 125 to the 2/3 in your calculator. You can do it in your head. It's the cube root of 125, which is 5, and then square it. So that's 25. 13 log to the base 5 of 125 times the square root of 5. So you could put this in your calculator with the log base formula. I like to just figure them out. So 5 to this power, the base to the power equals, I know 125 is 5 to the 3rd, and square root of 5 is 5 to the 1/2. So I have 5 to the x equals, I need to add those together. So let's see, what would that be? 6 over 2 plus 1 over 2 would be 7 over 2. So x is, once I have the same bases, I can set the exponents equal to each other. 14 log the base 6 of 18 plus log the base 6 of 12 minus log the base 6 of 6. So this is one of the laws of logs, where I just need to apply that law of logs to simplify this. and then I might use some property like I did in the other previous couple of problems to figure out what that log is. So one way to do that is I know that when there's addition between two logs and they have the same base, I can make that into one log and multiply those numbers. So this can be log to the base 6 of 18 times 12, which is 216. Okay, and then minus log to the base 6 of 6. And what I could do, I don't know that I even want to say because it could complicate things, but I could figure this out. Log to the base 6 of 216. And then I know that log to the base 6 of 6 is 1. So I could figure out what this is, subtract 1, and have the answer. Or I could apply the other law of logs, which says that if I have taking the log with the same base, two different numbers, I can divide those numbers if I'm subtracting. So I can make this log to the base 6 of 216 divided by 6, which is 36. And I know that that's going to be 2. I know it's going to be 2 because I set it equal to x. So 6 to the x power equals 36. 6 to the x power equals 6 squared. X equals 2. Okay, so I think that moves us to 15, which is log n over, can't read that, the fifth root of m. And it tells us that m equals x, and that log m equals x, and log n equals y. And we want to express this in terms of x and y. Okay? So there's the problem they gave us. So what that's telling me to do is I want to apply all the laws of log and separate those things out. Sorry. So I want to make this log n minus log of the fifth root of m. And I make it minus because division, that's what the law says. The division goes to minus, or minus goes to division. Either way. And then I need to fix this one up on the right. I'm going to leave this as log n, and I'm going to make this log of m to the 1/5. And I'm going to use the exponent law, which says if I have an exponent up there, I can pull that down and make it a coefficient. So I would have log n equals 1/5 log n. And now I can make those substitutions. Log of n is y, and the log of m is x. Y equals 1/5 x. That's what they're looking for. Okay. I need another sheet of paper. Here we go. So number 16, similar problem. Log of m to the 7th minus log of n to the 3rd. And really, all I need to do here is get rid of those exponents. So make this 7 log m. Oh, that's like way too many hills in my camel there. Minus 3 log n. And the log of m is x, and the log of n is y. So we're looking for 7x minus 3y on that one. 17. Radioactive element has a half-life of 16 days, and there's 800 grams, so the initial amount is 800 grams to start. How much will remain after 32 days? That's not a very smart question. Because 32 is 16 is a factor of 32, so that takes all the interesting stuff out of it. I really don't even need to use the formula for half-life. But I assure you, it probably is not going to be that way on the test. So when I was changing these numbers, I was obviously not thinking. What we're looking to use, A of t equals a sub 0 times 1/2 to the t over k, where k is the half-life of the element, a sub 0 is the initial amount, t is the amount of time I leave it in there. Okay, so to set this up, I need the initial amount is 800 times 1/2 to the 32 over 16. And that is 800 to the 800 times 1/2 squared, which is 1/4, and 1/4 of 800 is 200. And like I said, it is quite likely that this is probably not going to work out this way on the test. If it does, great, bonus, you know you're going to be right. If it doesn't, this is how you would figure it out. And then it says in the directions to leave your answer to the nearest hundredth. And then you should also label your answer with whatever quantity amount I gave you. So in this particular problem, it's grams. Okay. 18. If you invest $5,000, 1, 2, 3, at 6.25% compounded monthly, how much will you have to the nearest cent after 5 years? And then about how many years will it take to double your money? So compound interest, we're looking at A of t equals a sub 0 times 1 plus r over k to the tk. And r is the rate at which it's invested, k is how it's compounded, t is the amount of time. So for this problem, this is going to be 5,000 times 1 plus 0.0625 over 12 to the 12 times 5 power. And we can plug that in our calculator just like that. Let me see if I get this where you can see what I'm doing. So I'm going to have 5,000 parenthesis 1 plus 0.0625 divided by 12, close that parenthesis, up caret 12 times 5. And press enter, and that's the answer. 6828.6, and we're supposed to round to the hundredths place because we're talking about money, so that would be 6828.65. So 6828.65, and then we should write the $sign to put units on that. Okay, so there's our answer rounded to the hundredths place because it's money with a $sign. Okay, and then approximately how long is it going to take to double? We would use the rule of 72 and divide by 72 divided by 6.25. 72 divided by 6.25 is 11.52. I'm going to figure that out just for kicks and giggles. So if I'm going to double it, it's going to be 2 equals 1, but the quantity 1 plus 0.0625 over 12 to the 12 times 5 power. No, to the 12 times t power. Sorry. And why did I put it? No, that's right. Wow, really going stupid today. We want to see how long it's going to take to double, so we want to solve for t. So we take 1 plus 0.0625 divided by 12, and that gives us a really messy number. 2 equals 1.005220833. And then what we learned with the natural log is that we can use the natural log to solve this. So we take the natural log of both sides, the natural log of 2, the natural log. When I take the natural log here, I'm pulling this exponent down front. It's going to be 12t times the natural log of this stuff. 0.0520833. And then I solve that for t. So I take what I have in my calculator. I don't want to cover up the problem per se, but try to show you both. I have that answer still in my calculator. So I'm going to take the natural log of that answer. I'm going to go natural log second. The negative symbol is what you use for, I want you to put that, to tell the calculator, put that answer in there. And then I hit enter, and that's the natural log of that. Now I want to take the natural log of 2 and divide by that. So I'm going to take natural log 2. I should put a parenthesis. I'm going to put parenthesis, natural log 2, parenthesis, divided by the answer I got up here. So again, I go second, negative symbol, which is the answer, and hit enter. I'm going to divide that by 12. My answer is 11.12. So the rule of 72 told me 11.52. This is telling me 11.12. And to be honest, now I'm going to backtrack. I would not want you to use the rule of 72 here. The rule of 72 is for simple interest, and this wasn't simple interest. And that's why we have such a difference between our two values here. Okay, so you do need to set it up as an equation and solve the equation using the natural log. Okay. Number 19, as 5 to the x equals 40. And so I cannot match the bases here. 40 is a multiple of 5, but it is not a factor of 5, so I can't get them both the same base. So I have to use natural log. So here I'm going to have x natural log 5 equals the natural log of 40. So x is the natural log of 40 over the natural log of 5. And round your answer to the hundredths place. Remember, those natural logs do not cancel. I have to take the natural log of 40 and divide by the natural log of 5. And I get 2.292. And then the last question says simplify e to the ln of x. And the e to the ln of x is x. And that is all.